Now we are going to look at circle equations that's in non-standard form. So it states if an equation is not given in standard form, it can be rewritten in standard form by completing the square. So we had our algebra refresher. Now we're actually going to do this, completing the square, to write the non-standard form. So if you look at this example, it looks very scary. There's two squares in it, the x is squared and the y is squared, and we have other coefficients. So yesterday we looked at the normal standard form equation. And let's go back up here and refresh that. That is x minus h squared plus y minus k squared equals, and if you recall, it equals r squared. Okay, so that is the standard form of an equation for a circle. That looks nothing like that, but we can complete the square to make it look like that. There are 4 steps. Step 1, move the constant terms to the right side. This is the constant term because it does not have a variable. So we are going to say x squared plus y squared minus 10x plus 8y equals positive 8. So that's the first thing, move the constant to the right side. Step 2, group the x terms and the y terms together. So I'm going to put x squared, and I'm going to move the 10x right here. It stays 10x because I am not moving it across an equal sign. I'm just moving it with commutative property. I am intentionally going to leave a blank right here. And then I'm going to put next y squared, and I'm going to put 8y with it. And I am going to intentionally leave a blank here. And all of this is equal to 8. So I want you to notice the only thing that I've done is I've put x's together and I've put y's together. That equation is still the same thing. Now, step 2 is complete. Step 3. Complete the square for the x and y terms by adding b divided by 2 squared to both sides. So, negative 10, half of that is negative 5. Negative 5 squared is an add 25. But if I do it to this side, I must do it to this side. Now I have to do that for y. Half of 8 is 4. 4 squared is 16. If I add 16 to this side, I must add 16 to this side. Now, that is the complete the square part. Step 4 says to factor and simplify. Now, this is where the magic comes in. Only look at this and factor that. Well, that is x minus 5. X minus 5. So I can write that x minus 5 squared. Now go to this portion. This is y plus 4, y plus 4. So this is y plus 4 squared. So this part now becomes this, and if you'll notice, this now looks like this up here. This is equal to 8 plus 25 plus 16. Add those up, you will get 49. Now, if you'll now look at this, we now have a standard form of a circle. Now, the center of the circle, we can now see. The center is do opposite 5, opposite negative 4, radius, square root 49 is 7. So you have to be able to complete the square to get that non-standard form equation into standard form. Now let's move on. It says rewrite the equation in standard form, state the center and the radius. Okay, so we're going to go through the steps. First step, move 14 to the other side. So we're going to add 14. So we get x squared plus y squared minus 2x minus 16y equals 19. Step 2, group. X squared minus 2x, leave a space, plus y squared minus 16y, leave a space, equals 19. Next part, complete the square. Half of negative 2 is negative 1. Negative 1 squared is 1. If I add it to this side, add it to this side. Half of negative 16 is negative 8. Negative 8 squared is 64. If I add it to this side, add it to this side. Now, factor this portion. You will factor it, and you will get x minus 1 squared. Factor this portion, y subtract 8 squared, equals 64 plus 20 is going to be 84. There's my standard form equation. Center is going to be 1/8. Radius is going to be square root 84. Break down 84, okay? That is going to be 4 times 21. So if you break that down, the radius is going to be 2 square root 21, or if you type it in the calculator, it could be 9.2. Okay? Now, question 10 adds a step to us. It says translate this circle, 1 left and 2 down. We cannot do that step until we get the center of the original equation. So we're going to go through the process again, except this time I'm going to combine some steps. I'm going to move 20 over for a negative 20, and I'm going to go ahead and put these together. So I'm going to get x squared plus 6x, leave space, plus y squared minus 12y, leave some space, and that 20 is going to become negative 20. I am now going to complete the square. Half of 6 is 3, 3 squared is 9, add it to this side. Half of negative 12 is negative 6, negative 6 squared is 36, add it to this side. Now factor x plus 3 squared plus y minus 6 squared equals, okay, now this is negative, so when I put the negative with these two positives, I'm going to get a positive 25. Now at this point, that's the first step. So my center is negative 3, positive 6. That is the center. Now, if you have a circle, I'll use this example, and you have a center and you're translating it, you can just go ahead and translate the center. So 1 left will go with the x coordinate, 2 down will go with the y coordinate. So my new center will be negative 4, 4. So now, final answer will be x plus 4 squared, y minus 4 squared. It will still keep the radius. The radius would be 5, but for the equation, you're going to have 25. So, you have to follow these steps, and you have to have algebra skills to complete the square to do this. Now moving on and putting everything together is question 11. It says use the graph to the right to answer the following questions. A, write the equation for the circle. So the first thing we need will be the center. It is going to be 5, 8, or excuse me, 5, 7. That looked like an 8, but that's a B, so 5, 7. And the radius, easiest thing to do with the radius is just to count that right there. That looks to me like 5 units. So the equation for the circle would be x subtract 5 squared plus y subtract 7 squared, square 5, 25. That is the equation of the circle. Now B says use the equations to determine whether the line is tangent, secant, secant that contains the diameter, or none of these. So we are going to first do y equals 7. That is a horizontal line through 7. So that is that line right there. Well, it goes through the circle, so it's a secant, but it also goes through the circle at a diameter. So this one is going to be a secant that contains the diameter. Okay? Now the next one, y equals 1/2 x plus 1. Here is the y-intercept of 1, and it's got a slope of 1/2. So it's going to look like this. So it is not tangent to the circle, it just cuts through the circle. So we know that to be a secant. And now the last one, x equals 0. That is going to be a vertical line. And if you'll notice, it touches at B. So we know that one to be a tangent. Now the last question states, write an equation for the line tangent to circle A at D. Explain how you determined your equation. So the first thing we need to know is where D is, and if you look closely, here is D. And the coordinates for D will be 8, 11. So we need a perfect line tangent. So what does that mean? Well, we have a line going through right here, and if it goes through D, there is also a tangent line. So the tangent line's got to be perpendicular to this line. So the first thing we're going to do is we're going to find the slope of this line going through D. So 1, 2, 3, 4, 1, 2, 3. So the slope of that line is 4/3. For my line to be tangent, it must be perpendicular. So the perpendicular slope of 4/3 would be -3/4. So it's a slope of -3/4 that goes through 8, 11. So 1, 2, 3, 1, 2, 3, 4. This is the line that we're trying to find. Well, we can't see the y-intercept because it's off the graph, but we can use this point and this slope here, okay, to find the equation using point-slope form. So this is point-slope form. So y subtract 11 equals -3/4 x minus 8. So y minus 11 equals -3/4 x. That is going to give us positive 6. And then I'm going to add 11, and I get -3/4 x plus 17. So even though we can't see it up here, 17 is a reasonable answer for that. So the most important thing you need to know to do the lesson is these steps right here and all of your vocabulary.